All right, hello again. This is Jeff Scott of Blackhawk Technical College. I've been coming at you with lectures from the Starting Out with Java from Control Structures through Objects, 6th edition by Tony Gaddis. I've been going over the PowerPoints of this textbook that we're going to use for the 152-143 Intro to Java Programming class for the Spring 2016 semester at Blackhawk Technical College. I've done the first 8 out of 11 that I'm going to do, and I'm going to go through number 9 right now. Chapter 9 is entitled, as you can see here, Text Processing and More About Wrapper Classes. So we will introduce the wrapper classes, which we've already looked at a little bit, talk about character testing and conversion, talk about more string methods, the StringBuilder class, which is the string builder is to strings what the array list is to arrays. So it allows you to make mutable strings, so to speak. We'll talk about how to tokenize strings. You say, I don't know what that is. Well, when we look at this, for instance, if I were to put a period at the end of this, so if I said character testing and conversion with a character class, period, if I would break these up into tokens, I'd have 1, 2, 3, 4, 5, 6, 7, 8 tokens. All right. We'll talk about the wrapper classes for the numeric data types, and finally there's an example at the end which goes over this reader class. So we talked about the 8 primitive data types. I don't think I have to write them anymore. All right, they are for whole numbers, they are byte, short, int, and long. For numbers that can hold a decimal place, they are float and double. And for non-numeric values, they are char and boolean. As mentioned here, these are called primitives because they're not created from classes. What Java allows you to do if you want to is to use a wrapper class. So you could take a primitive variable and use it as though it's a non-primitive variable, for lack of better words. All right? Wrapper classes, as it says, allow you to create objects to represent a primitive. They're immutable, so once you've created them, you can't change the object's value. To get the value stored in it, you must call a method, and they provide static methods which can't be used. So, for instance, there's a character class that allows a char data type to be wrapped in an object. So you can do things with it. Things like this. You can check whether what you put into that character is a digit or a letter or either one. In other words, it's alphanumeric. If it's lowercase, if it's uppercase, if it's a space character. And there's other things that you can do with it too. You can run actual methods on it to grab that character and make it lower or uppercase and do other things with it. We talked about substrings in an earlier chapter. What's a substring? It's a string that's part of another string. There's several ways that you can use substrings in here, and some of them are shown right here. All right. You can check and determine whether a string begins with a certain string. So in other words, we've got a string here 407 years ago. Does it begin with 4? Well, that would return true. If we said 5 here, it would return false, type of an idea. Starts with by default is case sensitive, but you can do a check on there, all right, or you can convert it from upper to upper or lower case. Ends with is just the reverse. So it checks the end of a string to see if it ends with something. You can check different regions of a string. This stuff is so powerful and this stuff is used so much because so much of the information that is in systems is in a database. And you might want to look through a database and you might want to look through records to see if they hold certain values. Many of these values are going to be stored in there as strings. So you can do things, as it says right there, like index of, which returns the first location of a substring or a character in a string object. Last index of, which finds the last location of that character or whatever it is you're looking for in a string. They've got an example program here where you can go and search. So this will find the first R that's in there, so it'll find that one. This will find the last R that's in there, so it'll find what? That one. When you do that, typically, you check to see if it's not equal to -1, because, for instance, if I had said in there Bob Smith, maybe let's say that was my string, and here was just Bob Smith. There's no R in there. So typically you'll check And if there is no R in there, it'll return a position of -1, which means it did not exist. Here are some of the string methods that you can use. This is table 9.4. It's taken right out of your book. All right. You can extract substrings. As it says, the string class provides methods to extract substrings in a string object. It returns a substring beginning with some start location that you tell it and ending with an optional end location. So this says start at character 14, 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So this would say start with character 14, which is the S here, and return the rest. So that'll just return Smith, which it will put into last name. All right. And they're showing here exactly what's happening when you do that. The string class, as mentioned there, provides methods to extract substrings and store them into character arrays. There's a get chars and a 2-character array. We'll look at some of that stuff when we go through what's actually in the book. There's a concat, which allows you to concatenate 2 strings together. A replace, which allows you to replace one, all occurrences of one character with another character. And trim, which gets rid of leading and trailing whitespace characters. There's a value of. As it says, it can be used to return the string representation of a primitive or of a character array. And they show some examples right here. For lack of better words, it grabs a value that's a non-string and it converts it to a string. Here are some more examples. Now, with the string builder is similar to the string class, but it's mutable, which means that you can change its contents. As mentioned here, you can change specific characters, you can insert characters, delete characters, etc. So what I might do is if I wanted to create a program where I allowed a person to put in their first name, their middle name, and their last name, all right, what I might do is I might have 3 strings. 1 string for first name, 1 string for middle name, 1 string for last name. Then I might have a string builder where I create and put together the first name, the middle name, and the last name. Then I would take that string builder and I would copy that when it was all done over to another string that would represent the entire name. Why? Because again, string builders can grow or shrink in size as needed to accommodate any changes I might want to make. So I can create a string builder and put no number in there so it defaults to size 16. Or I can put a number in there. Or I can put an actual string in there. There's a bunch of methods that you can use with a string builder class. The majority of them are shown right here. Now when you look at it, you go, well, wow, those are pretty much the same things that we could use for a string. That's because that's what they are. A string builder is just a mutable string, so it can be changed. The string builder class has several overloaded versions of the append method where you can add things to a string builder. After append is called, as it says there, the string representation will be appended to the string's contents. So they show an example here. You could not do this if you were working with a regular string, but it will work with a string builder. So string builder has a lot of different overloaded methods for append. It also has a lot of different overloaded methods for insert. Again, we'll look at some of these examples when we get to the book part of the class. All right. It also has a replace method, which allows you to basically do like a replace like you would do in Word or whatever. So this comes through here and it says we want to replace the word Chicago with New York. So instead of saying we moved from Chicago to Atlanta, it'll say we moved from New York to Atlanta. String Builder also has methods to set and delete characters in an object, and they show you examples of that here. You can call the String Builder's toString method to convert the String Builder to a regular string. All right? And usually that's done. All right, tokenizing strings, I already mentioned that. when you tokenize right here, the reason that you can tokenize is you've got to have some character that says where each token is. So for instance, if I look right here, there's a blank space between each word. So that would be the tokenizing character. Same way here, there's a blank space. So if I do that and I run the split method on it, it'll grab that string, 1, 2, 3, 4, and it'll display it as 4 different tokens. All right. Java has several numeric data type wrappers. So notice the wrapper class looks the same as the primitive class, except there's a capital letter in there. So you can create objects from wrapper classes, and the reason you might want to do that is so that you can actually run different methods on those objects. And again, we'll look at some examples of that as we go on. Each of the numeric wrapper classes has a static method that converts a string to a number. You've already done this. You've done integer.parseInt, etc. Notice as it says, if the string does not represent a numeric value, automatically the parse method in Java will throw what's called a number format exception. All right. And as we finish up here, notice each of the numeric wrapper classes has a static toString method that converts a number to a string. Okay. And you can do a binary string, a hex string, an octal string, etc. Finally, the last thing that's discussed in here, what is it? Oh, I guess there's more. Sorry. They talk about boxing. Well, let's go to min and max first. Min value, all right, that is the smallest integer that the machine will hold. Max value is the largest integer, in this case, that the machine will hold. All right. Boxing and unboxing, as it says, if you declare a wrapper class variable and you assign a value to it, all right, it says if you do this, it says you might think that you may, not you may, it should be you may. Oops. Well, somehow I just, there we go. It should say you may think that this is an error. But because the number is a wrapper class, it does what's called autoboxing. So it boxes that up, and even though this is not a simple data type, it treats it as though it is one. When you go the other way, you do what's called unboxing to it. And I'll try to remember to show you an article that I found online about this that does a pretty good job of explaining it. It says you'll rarely need to do this, but it can be useful in certain situations. The chapter ends with going through this problem-solving thing, and if we have time, we'll take a look at that when I go through the actual stuff that's in the book. So that's everything there is for